We're studying, this whole chapter is called sampling distributions, but the exact statistic that we're studying today is p hat, and p stands for proportion. So let's look this way and look at an example. Suppose you like grilling out, well this is about a bag of briquettes. So if we have a 20-pound bag of briquettes, say there's 20-pound bag is one of those really big bags. So say there's 450 briquettes in it, and I want to count what proportion are unbroken. Thank you, Caleb. What proportion are unbroken? What p? And so I'm going to sample 20 out of the 450. And when I did that, we call it p hat. And p hat is a proportion from a sample. So Elena, once I put the hat on, it's from a sample. Okay. So we don't know how many in the manufacturer says that are complete, but we know that from the 20 that we pulled out of the bag of 450, that 87% were fine. They were unbroken. So is that a good, how good is that information? This is where we started yesterday. So Elena, sort of a repeat for you. I had a different proportion up yesterday, and I had the same question. How good is that information? So, how good is p hat? So, can you wax eloquent about that? We'll have Caleb wax eloquent. So, how good is that p hat? Discuss it for me. What would you say? It's a good estimate of the true proportion? Okay, we can't tell. What do you think?
It is the sample size is less than 10 times than a tenth of the population.
Okay. All right, I note that.
Trying to write the word bag.
How's that? How about p hat though? You think that's a good one? What about you, Allie? You wax eloquent.
Or hockle.
I've got one sample, size 20, out of 450, and I want to know if that's a pretty reliable information. So, recall what we talked about yesterday with the 1492 in Columbus. What was that proportion?
Don't you
42
have to,
or something?
find all of the ones?
Yeah, that's
that are
funny.
20 out of
What was that?
I know. It's not funny. I just
All right,
I just
she's
thought it was
coming
funny because I
closer to
wrote
the answer I'm
1942.
looking
find all
for.
of them because
All right.
you
Instead of
can't do it without
1492.
all of
All right.
them because it could be biased.
All right, so she's saying one sample does show you
said
some
1942.
information, but how reliable is just one sample?
But I
It
thought it was
could
funny
be,
'cause they both
but
ended in
we've
42,
used
but
this
they're not
word,
supposed
Elena.
to.
It's unbiased.
Because ended in 42.
And we have learned that p hat is an unbiased estimator. So that makes it sound like 0.87 is pretty good then. So what do you have to say about that, Bailey? What does
I have
this
a lot to say about
unbiased
that.
mean? We have learned that
Oh,
p-
just the when you the p hat of this thing is close to the p hat to the mean
To the real
of the
proportion?
population.
all right, the real p.
the real one.
Yeah. You're saying it is close?
Yeah, because
All
it's
right.
unbiased.
All right. Remember our discussion on unbiased? It meant that if p hat is not biased means that it's not perfect. So what if that's a very imperfect one?
Oh, never mind. No.
Unbiased means like if I take one sample, this could be above, it could be below. But if I take another one, that's what Allie was alluding to. If I take another one, if it will be just as many above as below. So that's what it means by unbiased. So that might be a very lousy proportion of how many in this bag are broken. So as Allie was pointing us to, the way we figured out, Allie, is what? You were saying it? Come on. You were saying it. Like you said, one p hat isn't going to tell
yeah,
us.
you have to have all of the possible
All right.
p hats.
Right, and of course that's called a sampling distribution. If we take every single sample that's possible from 20 size 20 from 450, and we actually plot the proportions. So I'm going to use little p's instead of dots. We're going to get a sampling distribution for p hat. We can do this with mu, with the median. We can do it with standard deviation. We can do it with any statistic. So the mean, it's kind of weird because now we have the mean of the proportions, or the mean of the mean, or the mean of the standard deviations. So once we do that, this number right here is very, very good. So it's a very good. Of course, we're not going to have every sample size of 20 out of 450, but we're going to take many, many, and we're going to approximate a good sample. So that's what we've been talking about. So yesterday, we, let's put in a little box what we're learning, what we've learned for Elena. So we actually did a generator of a situation, an animation, and we took thousands and thousands of Reese's Pieces, and we actually sampled. What was the sample size? We kept changing it, didn't we?
I don't know.
Remember?
Was it 25?
We started with 25, I think. All right, so we started with a sample of 25, and when we did that, we looked at how varied the responses were. Then we were looking at the proportion that were orange. So Reese's Pieces. Elena, do you know what color they come in?
Orange and brown and yellow.
Yeah, it says orange, brown, and yellow. So guess how many that the manufacturer says, Elena? What percentage are
I
orange?
think it's
Just guess.
33.
No, not too bad. It was 45. So almost half of them are supposed to be orange. Have you found that true? Have you counted them?
I count them every
All
time I
right,
eat
so
them.
they're saying the
Which is
true proportion, the true P, the true proportion is 45.45. So what we did is we had an animation on the computer actually draw samples of size 25, n equals 25, and we looked at each sample and saw what the proportion was orange, and then they graphed it for us. So when they did that, what was the shape? What was the shape of all this? Caleb, do you remember the general shape? I think I asked you yesterday to describe the shape when we drew all those Reese's Pieces and we graphed all the proportions.
It was roughly normal.
It was. So let's make a note of that in our box. So we will say the shape of p hat approaches normal. So it's often a normal distribution. And what did we find when we actually looked at the mean of all those p hats? You remember, Allie, how close did the mean of p hat come? Pretty close to 0.45 yesterday? All right, so we learned that the mean of p hat is equal to the actual proportion, which was I was trying to depict here when I was talking here. The true proportion is the mean of all the samples. And then let's talk about spread. I don't have anything to say about outliers. So the spread, however, is affected by something. And in some of your homework problems, it was a little tricky to tell if you understood it or not. Maybe you didn't understand it before yesterday's class, and now you do, hopefully. But we can't hold up that snapshot that I showed Caleb yesterday. Maybe that'll help. What day was that? Day 1 or 2, maybe? Here it is, day 2 notes. On day 2 notes, it looks like a little insignificant graph, but this principle will come up and catch you if you're not aware of what it means. And what happens here, we were taking a sample, and I'll show it to you, Elena, as they look up on. When you're taking a sample and the size of the sample was 100, look how much spread we have. The results were from 0.22 all the way down to, what's that number? Okay, so that's pretty big spread. But then we did the same thing, same population, but we increased our sample size to 1,000, and the spread tightened up. So, you see that, Allie? Do you understand how that works? Okay. So, let's make a note about that. As sample size increases, I'll say standard deviation, that's that's what we use to detect
Box is
spread,
not big enough for this shenanigans.
decreases. What's another word that we use for that? It starts with a V.
Variant.
Variation.
Variability.
We both got it wrong.
Alright. Variability. Alright. That's a box that collected almost everything we've studied in this section.